Here we discuss about case study probabilistic theory of the deep learning. What are the probabilistic model? Probabilistic model are an extension components of machine learning which aim to learn patterns from data and make predictions on new unseen data. They are statistical model. They capture the inherent uncertainty in the data and incorporate it into their prediction. Probabilistic model are used in various applications such as images and speech recognition, natural language processing, and a recommended system. In recent years, significant progress has been made in the developing probabilistic model that can handle large dataset efficiently.
Categories of probabilistic model. These models can be classified into the following categories: generative model, discriminative model, graphical model. Generative model. Generative model aims to the model that join discriminative input and output variables. These models generate new data based on the probabilities. Distributions of the original data set. Generative models are powerful because they can generate new data that resembles the training data. They can be also used for tasks such as image, speech and recognitions, language translations, and text generations. Discriminative models. Discriminative models aims to the model that conditional distributions of output variables given the input variables. They learn a decision boundaries that separate the different classes of output variables. Discriminative models are useful when the focus on making accurate predictions rather than the generations of new data. They can be used for tasks such as image recognition, speech recognitions, and sentiment analysis. Graphical model. These models are graphical representations to show the conditional dependence between the variables. They are commonly used for tasks such as image recognitions, natural language processing, and causal inference.
Naive-Bayes algorithm. So first step, collect a label data set of samples where each sample has a set of features and a class label. For each feature in a data set, calculate the conditional probability of feature given the class. Third step, this is done by counting the number of times the feature occurs in a samples of class and dividing by the total number of samples in a class. Fourth step, calculate the prior probability of each class by counting the number of samples in each class and dividing by the total number of samples in a data set. Fifth step, given a new sample with a set of features, calculate the posterior probability of each class using a Bayes theorem and conditional probabilities and prior probabilities calculated in a step 2 and 3. Sixth one, select the class with the highest posterior probability as the predictor one.
Let's see the advantage and disadvantage of probabilistic models. Advantage of probabilistic models. Probabilistic models are an increasingly popular method in many fields including artificial intelligence, finance and healthcare. The main advantage of this model is their ability to take into account uncertainty and variability in data. This allows for more accurate predictions and decision making, particularly in complex and unpredictable situations. Probabilistic models can also provide insights into how different factors influence outcomes and can help identify patterns and relationships within data. Let's see the disadvantages of probabilistic models. There are also some disadvantages to using probabilistic models. One of the disadvantages is the potential for overfitting, where the model is too specific to the training data and doesn't perform well on new data. Not all data fits well into the probabilistic framework, which can limit the usefulness of these models in uncertain applications. Another challenge is that probabilistic models can be computationally intensive and require significant resources to develop and implement.
Probabilistic deep learning. Extend traditional deep learning by incorporating uncertainty into the learning process, both in terms of model predictions and data inputs. These approaches allow model to quality their confidence in predictions, which is crucially for safety critical applications and situations with noisy or incomplete data. Key aspects of probabilistic deep learning. Uncertainty modeling. Probabilistic deep learning model explicitly represent through probabilistic distributions rather than just making point predictions. Bayesian neural network. A prominent example is Bayesian neural network, which model uncertainty over the weights activations of the network. Applications used in various fields including text-to-speech, self-driving cars and other applications where uncertainty is a critical factor. Advantages. Confidence estimations provides a measure of confidence in predictions, allowing for better decision making in uncertain environment. Robustness can handle noisy or incomplete data by incorporating uncertainty into the learning process. Explainability can provide insights into the model's decision making process by revealing the uncertainty associated with its predictions.